When we start to look at data that we've graphed, we have to talk about the shape of the data. And that also involves measures of variability and the spread of data. So if you think about the shape of data, once we graph things, they can have a different appearance, and that's what we're going to talk about a little bit. If you look at your notes, when we describe the shape of data, we look at how it's distributed. And our baseline is the normal distribution, and we call that a bell-shaped distribution, where most of our data is towards the middle, and then they're sometimes symmetrical. If they're perfectly symmetrical, then the mean would be the same value as the median, which would also be the same value as the mode. Typically that's not the case, but it could happen if it's a perfectly normal distribution or a perfect bell curve. More likely what we're going to see is a skewed graph, and what that means is you're going to have a longer tail to the right or to the left. If it's skewed right, I have a longer tail here, and that means I have a positive skew. Remember that right in math is your positive direction. So in this case, if you look at what happens here, the mean is going to be not exactly in the middle. Here's the exact middle of the curve, but the mean is not in the middle. And that's also the case when we have a negatively skewed graph. The mean has been pulled a little bit towards that longer tail. So if our data is skewed, the mean is not going to be our best measure of central tendency because it's been kind of pulled to the left or the right by that longer tail. Take a look at the graphs on the bottom and determine if they are a left or negative skew or a right or positive skew. And you can pause here and come back and check. So the first graph has a little bit of a longer tail to the left and a little bit of a drop there. So this is a left. Below that we have a right skew because my bell has a little bit of a longer tail to the right. This one also has a longer tail to the left, and this one would have a little bit of a longer tail to the right. And then this is a perfectly normal curve. Now, before we go on, we want to talk about measures of variability next, or the spread of data. And I'm going to ask you to go forward in your notes to look at dot plots. This is a very simple graph in which each dot, or you could use an X, represents one piece of data. It gives a very quick overview of the spread and the mode. Outliers are easily visible. We want to make sure our line is equally calibrated, and we don't want to forget a title. So we use a dot plot when we need a quick reference, and also when we want to graph each piece of data. And we won't always be doing that, as you will see. So to draw a dot plot, these are pretty easy. You need to determine the highest and lowest values. You draw an equally divided number line that starts at the lowest and finishes at the highest. You place a dot above each value as you cross them off. The dots need to be similar sizes, and they need to be evenly spaced to give an accurate picture. So if we look at our data values here, the ages of audience members at a concert, if you look for your lowest value and your highest value, you will find the lowest value here is 10 and the highest value here is 17. You are going to need a ruler because you need to make sure about this equally calibrated part. You want to get a ruler and you want to draw a line. On your line, you want to equally calibrate between 10 and 17. So whatever you need to do there, you can use centimeters, half centimeters, inches, half inches, and make a line similar to mine. And then all you're going to do is you're going to place dots above each value. So what I'm going to do here is I can use X's or dots. I may just use X's this time. So I'll place an X for each value. So I can go through, I can place a 12, a 14, a 13, an 11, I already did the 10, then I would do a 16, and I would go along like so. So go ahead, pause here, and create your dot plot for this first set. As you can see, I created my dot plot here, an X plot really, and the last thing I need to do is make sure that I have a title. Now you want to look at your values to make sure that they're all kind of in line. Now you don't have to do this next step, but see how my X's are all kind of lined up and I have an equal number of space between them. That's important because I want to look at the shape of this data. Now this one's a little off. I don't actually like that. I would move that X up a little bit. You want to have equal spacing so that you can kind of look at what's the distribution like of my concert goers. So why don't you try the next one on your own and then come back and check with me. So in the resting pulse rate of students dot plot, I actually use dots this time. It doesn't matter. You can use X's also. They're fine. Make sure you have a title. And we can see that our data is pretty spread out, but I can easily determine the mode. I have a mode of 64. It's somewhat bell-shaped, but definitely skewed to the right. And that's kind of what we're looking for with the dot plot. It's a quick way to determine and describe our data. So if you look down below, some of the descriptions again that we can use are symmetrical. We can have a skewed to the right, skewed to the left. Here's a bimodal, although it just doesn't look bimodal. If it had another dot, it would be. And this is kind of uniform. So it's easy to determine what the shape of our data looks like. Now, another measure of variability is the range, and I'm sure you've heard of the range before. That is the difference between the highest and lowest numbers in our data. It tells if our data is closely grouped or spread out. So in the first example, I take a look at my quiz scores, and range is between 25 and 28, and that should just be a 3, not a 23. So most students scored about the same. If the range, however, was between 25 and 3, and I had a 22 for my range, that's a pretty spread out set of data. What you probably have not heard of before is the interquartile range. And in order to determine the interquartile range, I'm going to take you forward in your notes again, and we're going to go look at box and whisker plots. So if you want to pull that page up, it looks like this. These are graphs that break the data into quartiles, so quarters. Okay? And the box represents the middle 50%, the whiskers are the other 50%, and the endpoints are my maximum and minimum. Now this is going to seem a little weird to you at first. Trust me, they're not that bad. If you look at this little diagram, this is a box and whisker plot. And what it's saying is that within this box, I have 50% of my data. My whiskers are each a quarter of the data. So the very middle line there is the median. And then we find the median of the lower half, which represents this line. The median of the upper half is this line, and they're considered quartiles. I'm going to talk to you about all these terms, so don't get too panicked in this point. So box and whisker plots are used when we want to break up the data into quartiles. They are pretty visual. So let's look at what all of this means. Trust me, by the end of this, I think you'll understand it. We want to take our data and we want to break it up into quartiles. So to create a box and whisker plot, the first thing we do is we put the data in order. You guys can pause here and do that on your own. You should have your data in order, and now what we're going to do is we're going to divide it into quarters. So as you can see, there are 13 pieces of data. So if I go to the middle, my middle score is going to be right here. And then if I break down below it, the middle is going to be there, and the middle is going to be here. And basically that's all we're doing. So if I divide this into quarters, I have 2, 3, 3, then that's quarter 1. 5, 6, 7. My 9 is my quarter 2. That's the median. And then 11, 12, 12. That's going to be quarter 3. And 15, 16, 17. So if you look at this, I now have, this is kind of my middle. I won't always have a middle. It might be an even number of scores, and then I wouldn't have a middle. But I would do the same thing that I normally do with a median, and that's take the average. So let's find out how we do that. I know I have a quartile 2. My quartile 2 is 9. To find quartile 1, I take the average between 3 and 5. So it's 4. And then I'm going to take the middle between 12 and 15 for quartile 3. So 12 plus 15 divided by 2 is 27 divided by 2, or 13.5. Notice that each of these quartiles, these are a number. So if you look at this, what we're going to do next, just like we did for the dot plots, is create a number line. Now your number line has to have your lowest value and your highest value on there. So my lowest value was 2 and my highest value was 17. So now what I'm going to do is I'm going to put a little dot here above 2 and a little dot here above 17. Those are my maximum and my minimum values. My first quartile, we'd figured out, was at 4. So I'm going to put another little dot there. And my median was at 9. That's quartile 2. And my third quartile is 13.5, so I'll just go above 13.5 there. And then all I do is I create, these are my whiskers, okay, they're the maximum and minimum values there. And then I create a box around quartile 1 and quartile 3. And then I draw a line at the middle. This tells me how my data is spread out. It's pretty balanced here. My median is in the middle of basically those scores, and my box is pretty even, and my whiskers are pretty even. Not totally, but pretty even. So that's how you create a box and whisker plot. Now we need to go back and talk about the spread of data in the interquartile range. So because we've created this box plot, it makes our interquartile range pretty easy. This is the difference between the third quartile, which we just talked about, and the first quartile. And that's all it is. It's a range between quartile 3 and quartile 1. It tells us about the range of the middle part of the scores, because remember in my box and whisker plot that I had, if we go back to this diagram quickly, I have it broken up into quarters. Basically, this is 25% of my data, this is 25% of my data, this is 25% of my data, and this is 25% of my data. So if I'm taking the difference between quartile 1 and quartile 3, that's going to be what is the range here. That's the interquartile range. That's all that is the range. So let's go back to this page. And if we look at the set of data, it's just going to go through setting up a box and whisker plot again. What I do is I put them in order. That's step 1. I divide that data into quarters then. Now in this case, I had exactly 12. So my quartile 2, which is right here, is between 10 and 11, or 10.5. This is also my median. Quartile 2 is the median. Quartile 3 is between 14 and 16, so that's 15. Quartile 1 is between 4 and 4, so it's just 4. Okay, the quartiles are a single number, not a range. And then I just take the difference between my third and my first quartile, so that would give me 11 as a final answer. And again, here we have our box and whisker plot, and as you can see, we have the 25% of the data in each of these ranges. If I look at this box and whisker plot, it's going to tell me a little bit about how the data is spread out. I have a big range here of data and not as big of a range here. And this whisker, however, is shorter than this whisker. So this 25% of the data is more spread out than this 25% of the data, but the 25% of the data within the box here is more spread out than that 25% of the data. So it just helps you to describe all of your points in your graph. Great job tonight, ladies and gentlemen. I will see you tomorrow for more boxes and whiskers and dots and X's and all that fun stuff. Have a great night.